Very warm welcome to everybody, and welcome to this roundtable from Wejo. So the roundtable today is going to be around, I suppose, more the societal benefits and opportunities of connected vehicle data. So I suppose by way of an introduction, I'll introduce myself first. So I'm Matt Blackwell. I'm a solutions engineer with Wejo. Been with the business around 4.5 years now. I suppose where my primary focus is around the kind of product development and the client-facing side of the business. Jim.
Thanks very much for that, Matt. My name's Jim Eaton, a solutions engineer sitting alongside Matt in that department. My focuses are in terms of government, municipality space for some of our enterprise partners producing bespoke solutions with our connected vehicle data. So I'll pass to yourself, Steph.
Thanks, Jim. So my name's Steph Ayres. I've been with the business now for around 3 years. Always focusing on our sales and commercial side of our business. Right now, my role within Wejo is the SVP of Enterprise and Channel Partnerships. So my team work with some of our largest customers, both in co-product creation and also in understanding how we can reach most end users in various marketplaces. So really looking at how we distribute our products and our services to as many customers as possible.
So I think in that then, to get us moving, Matt, you talked about the subject that we're here to talk about today with you guys. Ultimately, I think the starting point, let's have a brief recap on connected vehicle data. So I think that's the real starting point for us. Connected vehicle data, by Wejo's definition, is data obtained directly from a fleet of connected vehicles, of which Wejo currently has 10.6 million. What it means in regards to societal benefits is ultimately some of the attributes that we can obtain from that. So I guess if we, as a group, sort of have a bit of a dialogue about those attributes, that could be a great starting point.
Yeah, I think certainly from my perspective, when we start to look at, we talk a lot around. Our key mantra is around data for good as a business, and there's not a lot of businesses that can truly say that they prescribe to that mantra. So there's probably a few things I'd quite like to talk about today, which are things like the benefits from a safety perspective. Now, safety is a really, really broad topic when you talk to any of the agencies or any of the kind of public sphere companies as well. But safety in itself, there is a societal benefit to everybody when it comes to safety. But I think as well, when you start to look at the benefits around just general congestion, who wouldn't want to spend less time in traffic? Let's face it. So, the data for good has, from a safety aspect, but then also from, cutting 5 minutes out of your journey. So,
in terms of our core attributes, we look at things that help us understand the movement of vehicles. The difference with connected vehicle data is that it's much more granular. So we receive a ping from the vehicle every 3 seconds, which tells us the whereabouts of that vehicle, making it much more accurate. And I mean, just common piece of feedback that we get from customers is around the amount of data that they have to filter out. Now, normally, that would be around 40% of data points. They would have to filter out some of their core data sources at the moment. With Wejo and connected vehicle data, that's less than 0.0001%. So that just goes to show how accurate connected vehicle data is, specifically in those transportation and hence those safety type use cases.
Yeah, I think that's a good point you were talking about there, Steph, really, in terms of we have sort of two distinct data sets with two distinct supporting both from your perspective, Matt, what you mentioned there around reducing traffic, reducing traffic in a given location will help people move less. How can we put that changes the behavior of the drivers to be less erratic because their trip is a little bit smoother, all that good stuff that goes with that. And then there's the true kind of measures that's exclusive for connected vehicle data, and particularly stuff that Wejo can get a hold of, such as the harsh braking, harsh acceleration event data that, and I guess, Matt, you might be able to talk to this as well in some detail, that this is something that isn't accessible on the market currently. This is something that is, how should we put it, when it is available, it is very, it's within the scope of years and months rather than the sort of the paradigm shift, I guess, that Wejo can provide it in terms of a daily delivery. So I don't know if we wanted to start moving towards that part of the conversation.
Yeah, absolutely. I mean, when you start to look at, I suppose, situational data on the roads, being able to pick up on things like driver behavior is very, very difficult from a lot of data sources, and that's certainly what I've seen from connected vehicle data. Is we actually there's not many businesses that can actually have the stance of we have actually been instrumental in making roads safer. If you look at some of the data sources that are out there, they will be intermingled with a lot of different data sources, and it tends to blur the lines as to the true benefit. Whereas with this being a solely connected vehicle data source, actually being able to influence even one less fatality on the roads for us as a business is a use case that we see more and more and more of, and we are very, very passionate about as a business. It wouldn't be right of me not to mention things like Vision Zero as the big initiative in the US. You look at, I think I read a stat the other day of about 37,000 fatalities on US roads every single year. If we could even influence 1% less of that number for us as a business, that would be our raison d'etre as a business.
Absolutely. And I think just to that point, Matt, of driving behaviour during 2020, now initial thoughts there would be there's less traffic on the roads because of the impacts of COVID-19. In actual fact, what that article told us was that there'd be more fatalities through crashes in 2020 than any other year. That's because people are speeding, they're driving faster because there's less congestion. And actually, that's why connected vehicle data really comes into its own, because of the high capture rates, because of the low latency, so how quickly we can get that to an end user. Adaptations can be made to those roadways, such as variable speed limits, as an example, that can help these types of use cases tremendously.
Jim, I know you'll have a lot to add to this, but when we start to look at GPS and location data in general, is that's fine. But when you start to look at more situational data, and I can hold my hands up on this and say I've used apps in the past that monitor your driving. Now, the second you're being monitored, you change and adapt your driving behavior.
Yeah.
With a connected vehicle, because it's embedded technology in the vehicle, most drivers will not even know that it's there. So when we start to see instances like hard braking, like seatbelt unlatch at 80 miles an hour, and believe me, we do see it. We can really start to influence those models in comparison to the mobile data, which potentially does have that skew in terms of the profile.
I think you referenced a good point there, Matt, in terms of that, other data sources are provided from fleets of vehicles that already have a leaderboard of some description within that organization to ensure that they're driving a particular way. So in study of that kind of data set, it would give you an idea of everything is fine, everything is moving accordingly all through various location. But I guess what I'd sort of dip into next is sort of if we think about the more recent unfortunate events that happened in Texas and where Wejo's data can come in to start to identify queuing traffic, for example. That's just one of the aspects from what you were mentioning there, Steph, around the real-time element of our data, the granularity of our data to identify behaviors that perhaps might be difficult to spot using other data sources. I guess there's sort of channeling sort of that thought leadership element and where this could go sort of next. So I guess in some of that pieces, the attributes that we're starting to pull in now to understand, how could we put it, more situational analysis around whether at that given location, that also ties in with that element that I just mentioned earlier on. If you start to think about that in terms of that at a granular level of what was the factor, what was the reconstruction of this event, and if that same series of events occurred again, what could be mitigated to resolve that? So I guess that's sort of, we start thinking about that thought leadership element of it, of what next.
And I think being more kind of, I suppose, wider than that, we start to look at localized weather events and the rolling blackouts in Texas and people actually switching their cars on just to get warm has never been seen, and hopefully will never be seen again. But when you start to look, I suppose, more widely at more natural disasters, so things like on the West Coast, huge amounts of earthquakes, wildfires. Again, you can actually use data to understand, okay, how are people behaving during those particular incidents? And again, I'll probably bring this back to mobile data in a sense, because when you're all of a sudden having to, evacuate your area, evacuate your house, typically what will happen in those instances is cell network connectivity will be focused purely on a particular app or something to be able to broadcast to local people, or okay, you need to vacate the area.
Yeah.
Typically in those instances, GPS location takes a backseat to being able to broadcast that information. We don't have that same issue with connected vehicle data, because the vehicle itself is transmitting. Then we don't have that same issue, and we can understand, okay, what are the, in real time, and this is as well, this is not just okay, how have people behaved in the past. On a real time basis, when we are having to evacuate a particular area, how are people behaving, and actually is there a way for us in real time to influence the evacuation routes?
That's one of the main topics that our customers really really love about our data. Is they have to look back at historic data sets to understand what happened in certain areas or on certain segments of road. And that's all with the intent of improving the way that we live and we travel. But understanding where there is a likelihood to be an event. Now, let's say that's a crash, a high impact crash. How great would it be not to have to look back at all of the data that has been over the last 6-7 years, but be able to see in real time what the behavior of that traffic is. So not where accidents have happened, but where there is a propensity of one to happen. And that's where intervention can be made before the event to make sure that there are less crashes of severe impacts, kind of what Matt mentioned before in terms of the zero vision.
That's, again, a great point that you mentioned there, Steph, in terms of talking about the historical view, that trend, that modelling over time of an incident at a location, to say, if I was a planner or I was a DOT, I could analyse from a wider view from actual vehicles now to understand, well, where would be my primary, secondary, tertiary location to mitigate risk to make the biggest impact in my Vision Zero scores, as you mentioned there, Matt, as well. I think this is an interesting piece that I know, Matt, you'll talk to this in quite some detail more than I can, around a piece of work that we recently did with a university in Purdue. So Purdue's study, paper, was sort of talking around 140 or so incidents, I think, Matt, that related to, 140 harsh braking events, should I say, related to an incident, perhaps. But I think that's probably an interesting point for us to dip into next.
Yeah, and again, it's that theme that keeps coming up time and time again around safety. And there is not a company that I speak to that doesn't have safety as their paramount concern, and where anything they can do to influence that. But absolutely, the work that we've done with Purdue University, 147. You were pretty much bang on there, Jim. 147 hard braking events leading up to an incident. So again, we find the data itself correlates very, very closely with known crash data. So if you look at, for example, the RITIS system, which typically will capture a lot of information, excuse me, on known crashes, again, there is a slight bias for that, because you have the attending officer who may attend an hour down the line, may report actually the incident occurred half a mile down the road. And actually, when it comes to road planning, that's a huge discrepancy. Whereas we know precisely down to the 3 meter square radius where exactly those harsh braking events are occurring. And I think probably we've started to really do some real in-depth work around, okay, so we have the hard braking, which is a really good indication of where things have a propensity to happen, but how can we start to influence the market on when are things actually happening? So a good example of this would be, when we start to look at things like airbag deployment. Now, airbag deployments don't go off, just every now and again. It's only when an accident has actually happened. So we're able to actually reduce the false positives that a lot of these agencies are working with at the moment from typical data sources by saying, okay, an airbag deployment has happened at this time, at this point on the intersection. You have cameras. You can be able to mitigate any secondary crashes. And again, secondary crashes is a huge focus for a lot of the traffic management centres and the agencies. And being able to mitigate secondary crashes just isn't possible at the moment without knowing where to focus that resource and where to focus the attention. So
I think that's again all really interesting points, Matt, in terms of, well, know more precisely a behavior that would be like harsh braking, harsh acceleration events and one behavior, and that secondary, tertiary kind of incident in and around it. Mitigating factor of safety. So we see seatbelt latch and unlatch, and I think you talked about it. We see quite a lot of those quite high speeds. So if you imagine that as sort of a campaign, recent US campaigns would click it or get a ticket. So you could say in a given location, given area, how many vehicles was, how many changes of status did Wejo see over a course of time, run your campaign, and then run that same study in another location. So that again gives that idea of, well, that's that kind of validation that what the local government, DOT might be implementing is actually making an impact on what they're actually trying to set out. So it's that kind of validating your work ultimately in that instance.
Yeah, and when we start to look at road conditioning, a lot of the agencies and the DOTs will rely on, typically this tends to be roadside sensors. So we always make the analogy of, well, if you look at it, for example, with some of the elements that we're getting from our latest OEM, we have 150,000 mobile weather sensors. Now that's not stretching the truth by any means, because we are understanding, okay, at what point do they switch the wipers on? How intense are those wipers? And actually, what was the ambient temperature at the time? Because I didn't know this until recently, but Texas has a huge problem with hyperlocalized weather, like literally down to and I've seen it when I've been over in the States myself. You drive through rain, and then all of a sudden it's like a curtain, and through the other side, a few meters down the road, it's fine. Actually, unless you've got a weather sensor positioned specifically on that piece of road, you can't gather, okay, when are people switching their wipers off? So that that analogy of 150,000 mobile weather sensors, it's not stretching the truth by any means. That's exactly what we have in the data asset.